how much problem do you see when you look at the classic Cloud Foundry users, which comes through the tribal knowledge that was built within the team? And if that a person moves out of the company, they take that knowledge with them, or they build so much technical debt that is challenging for them to even migrate.
Well, if you're a Cloud Foundry user, one of the first things you have to learn is how to use build packs. And build packs, are technology on its own that, for example, are competing with other approaches to create container images, including, using, something like a Docker file. That knowledge won't go away. For example, you can use build packs with Kubernetes easily. There are several ways to do that. There's Cloud Foundry on Kubernetes. There's KF for Kubernetes. There's just the ability to create your own container image in a CI/CD pipeline using build packs, and then use the container images as you would with other non-build pack container images as well. So from that perspective, I would say, using Cloud Foundry means understanding 12-factor apps, means understanding cloud native application design. And that's best practice on Kubernetes too. The way you split responsibilities in Cloud Foundry, for example, there are the applications, there are the backing services, is similar in Kubernetes. It's just that Kubernetes provides you with more abstractions that you can, for example, also automate the lifecycle of message queue and even a database if you really want to. So it's not that you have, there's your application runtime, that's Cloud Foundry, and there are the, let's say, the anynines data service that will integrate with their service broker into the marketplace. In Kubernetes, you can do that, and it's meaningful, especially if you run Kubernetes cluster in a data center where you already have that virtual machine-based automation. It makes more sense to integrate that virtual machine-based integration to get a Postgres database, for example. You'll have better noisy neighborhood isolation, for example, in contrast to an operator-based Postgres where you have pods. So if you take that, a lot of the knowledge that engineers build in either of those technologies, they come to the same mindset because it's the underlying learnings from running software for decades. For example, the separation of the ephemeral virtual machine or container from the persistent disk or persistent volume is one of the key learnings that is again the foundation of declarative operational models, whether it is a Kubernetes stateful set or whether it's a BOSH-based deployment. They follow the same basic ideas, and as long as engineers grasp those basic concepts, they'll have faster learning, whether you come from Kubernetes and go to Cloud Foundry or the other way around. With Kubernetes being more flexible, there's more to learn about Kubernetes, and there's more freedom. There are more, it's always like dealing with a two-edged sword. You can cut yourself much more easily, but you have more freedom to do whatever you want to.